Hello and welcome to Science Education. In the last lecture, we have seen exercise 5.1, question number 8 and question number 9. In today's lecture, we'll see some more questions. So let us start. Here we have 10th question of exercise 5.1 and the question is, find all the points of discontinuity of a function f of x is equals to x plus 1 if x is greater than and equals to 1 and x square plus 1 if x is less than 1. So here we have three cases. C is greater than 1, then C is equals to 1, then C is less than 1, right? So let us start with C is less than 1, then we will continue with C is greater than 1, C is equals to 1, and then we will continue with C is greater than 1. So first of all, let me write, let C be a point on real line. Then what we can say? We can say that C is less than 0, C is less than 1, C is equals to 1 or C is greater than 1. So if, let me move to the next page. So first of all, if C is less than 1. Now we'll check the continuity of a point which is less than 1, right? If C is less than 1, then f of C is equals to, now what is our function when point is less than 1? Our function is x square plus 1 whenever point is less than 1. So let us write, it is C square plus 1, right? We will replace x with C. Now let us find the limit of the function. So now limit x tends to C f of x is equals to, so let me write it here, is equals to limit x tends to C x square plus 1 is equals to C square plus 1. So here, as you can see, both our function and limit are equal. So we can write limit x tends to C f of x is equals to f of C. So that's why we can also write that the function is continuous at C less than 1. So we can write f is continuous at all point when x less than 1. Okay, now let us move to the next one. Next we have second case, which is if C is equals to 1. So if C is equals to 1, we have to check that it has to be continuous at 1. So how we will check that? So if C is equals to 1, what we have to check? We have to check that right limit of a function at 1 and left limit of a function at 1 should be equal, and that should be equals to 1, f of 1. So first of all, what will be our f of 1? Whenever x is equals to 1, our function is x plus 1. So f of 1 is 1 plus 1, which is equals to 2. Now let us find left limit first. So limit x tends to 1 minus. So left limit will be limit x tends to 1 minus x plus 1 is equals to 1 plus 1 is equals to 2. So this is our left limit, this is our f of 1. Now let us check our right limit at 1. So limit x tends to 1 plus f of x is equals to, sorry I have made mistake here it should be x square, because left limit means all the points which are less than 1. So all the points which are less than 1, we have here x square plus 1. So for that we have to write here x square plus 1. So it doesn't change our answer, but it will change our calculations. So 1 square plus 1, which is 1 plus 1, which is 2. So it is really important that you write calculative part also the correct. Otherwise you will get less mark, or you will get your answer wrong. So limit x tends to 1 plus f of x is equals to limit x tends to 1 plus, now here it will come x plus 1, which is equals to 1 plus 1, which is equals to 2. So we have left limit, which is equals to right limit, and which is equals to f of 1. So we can write it like this: limit x tends to 1 minus f of x is equals to limit x tends to 1 plus f of x, which is equals to f of 1. So we can say that the function f is continuous at 1, right? Now we have to check whether our function is continuous at all the points which are greater than 1. So now if c is greater than 1, then f of c will be x plus 1, right? Why x plus 1? Because our function f of x is equals to x plus 1 whenever the point is greater than 1. So here we have to write c plus 1. So c plus 1, because we are replacing x with c. Now let us find the limit of a function. So limit x tends to c f of x is equals to limit x tends to c x plus 1, which is equals to limit x tends to c, which is equals to, you have to just simply write, you have to put limit and we get c plus 1. So I am writing it here, c plus 1, right? So here you can see that our f of c is c plus 1 and our limit is c plus 1. So we can simply write that limit x tends to c f of x is equals to f of c. That's why we can write, therefore f is continuous at all points which are greater than 1. All points x greater than 1. Right? So, here we have seen that the function is continuous on real line. Right? At each and every point on real line. So, the function has no point of discontinuity. So, let me write it. We can write therefore f has no point of discontinuity. So that is our question number 10. Now let us move to the question number 11. So our 11th question is f of x is equals to x cube minus 3 if x is less than or equals to 2 and x square plus 1 if x is greater than 2. So similar to the 10th question, here also we have 3 cases. So let C be a point on a real line Now, we have 3 cases for C. The first one is C less than 2. The second one is C greater than 2. And the third one is C is equals to 2. So, one by one, we will check for the continuity at these 3 cases. So, first of all, if C is less than 2. Now, if C is less than 2, then our function f of C will be. Now let us check what is our function whenever a point is less than 2. So whenever a point is less than 2, our function is x cube minus 3. So let me write it here. So x cube minus 3, that means c cube minus 3. So this is our f of c. Now let us find the limit of a function. So limit x tends to c f of x is equals to limit x tends to c x cube minus 3, which is equals to c cube minus 3. That means our f of c is equals to our limit x tends to c. Right? So here we can write therefore limit x tends to c f of x equals to f of c. So our function is continuous at all the points x where x is less than c. So here we can write therefore f is continuous at all points x where x is less than 2. Now what if x is equals to 2? This is our second case. Now if x is equals to 2, then first of all f of c will be. Now let us check what is f of x when x is equals to 2. Now x is equals to 2, then f of x is equals to x cube minus 3. So our f of 2 will be, here we have to write f of 2, here it will be c, and here we have to write f of 2. So let me write it here. So c is equals to 2, then f of 2 is equals to x cube minus 3. That means 2 cube minus 3. Now what is 2 cube? 2 2s are 4, 4 2s are 8. So 8 minus 3, which gives us 5. Now we have to check our left limit and our right limit at a point 2. So first of all, left limit of a function will be limit x tends to 2 minus f of x equals to limit x tends to 2 minus x cube minus 3, which is equals to which is equals to 2 cube minus 3, which is equals to 8 minus 3 equals to 5. So here our left limit and f of c are equal. Let us check for our right limit. So limit x tends to 2 plus f of x is equals to limit x tends to 2 plus. Now what is the function f of x whenever x is greater than 2? So whenever x is greater than 2, our function is x square plus 1. So let me write it here. X square plus 1, which is equals to 2 square plus 1, which is equals to 4 plus 1, which is equals to 5. So it is clear that our function is continuous at point 2. Why? Because our left limit is equals to our right limit, and which is equals to f of 2. So here we can write limit x tends to 2 minus f of x is equals to limit x tends to 2 plus f of x is equals to f of c. That's why we can say that f is continuous at x is equals to 2. Now if c is greater than 2, then f of c is equals to x square plus 1 and f of c is equals to c square plus 1 and limit x tends to c, f of x is equals to limit x tends to c x square plus 1, which is equals to c square plus 1. So here you can see that our f of c is equals to limit x tends to c f of x. That's why we can say that f is continuous at x whenever x is greater than 2. So our function is continuous on all the points, at all the points on a real line. So that's why f has no point of discontinuity. So f has no point of discontinuity. So that's it for today's lecture. If you like our lecture, then subscribe our channel and keep watching. Till then, goodbye. Take care.